Sound needs continuous movement. This statement became increasingly clear as my group progressed in our music-making journey, using speakers and amplifiers in combination with an electromagnet process. Before we could use our tools to make music with speakers and amplifiers, we learned to create an electromagnet by connecting the positive and negative terminals of a carbon zinc battery to a nail using alligator clip wires. We had success in picking up attractive objects such as paper clips with the nail tip. Then, we removed the nail and used a semiconductor in the form of a light-emitting diode, or LED, to create not only light, but also a gentle, high-pitched sound, after we attached a resistor in between extra alligator clip wires before the electricity reached the LED to reduce current flow. With the resistor, the sound came in waves and the light emission became fainter due to the limitation of electricity. Then came the time to work with the tempting speaker we had been given. We removed the light-emitting diode and clipped the alligator wires to the speaker, but nothing happened. To make the speaker move, we needed to remove the resistor from our process, as there needed to be an adequate amount of electric current for the speaker to do its job as a transducer, which turns one form of energy, this being electricity, into another form, which in the case of speakers is sound through the movement of vibrations. Likewise, we needed to apply continuous movement with the alligator clips by connecting one wire directly from either the positive or negative speaker terminal of the battery to that of the speaker to reach its interior, which contains a magnet wrapped in copper coiling, connecting to the speaker cone which moves air to create sound with vibrations or movement. With a magnet being the reason a speaker works, it is understandable that a resistor prevents the sound from occurring as the magnet requires sufficient electric current for the repulsion and attraction, which rises or lowers sound, to occur within. On the other terminal, a broken circuit, which is used to create light switches, was formed by attaching a wire to the speaker terminal and another wire with one side clipped to the remaining battery terminal and the other side to a metal object like a bolt. Then, by scratching the empty clip against the bolt's surface, we created sound! We could also include different metal objects in between, like we did here with a screwdriver, and it still worked because the electric current was being transferred throughout each wire and object just the same. To create a whole piece, we combined the electromagnet speaker's sounds with those of an amplifier. The amplifier used electromagnetic pickup where positive and negative wires connected to its interior, which contains a similar speaker to the one used inside of our sonic cup, creating sound whenever a metallic object came near or touched the magnets. One might shake a wobbly metal plate or hit a gong near the magnet to create repetitive sounds, but we used movement by tapping on and waving above the magnet, which relied on our movement. Here is the best result from the combination, where the scissors made an almost squeaky or disc jockey turntable sound when playing for the amplifier, and the speaker connected to the battery created a deeper sound reverberated inside of the larger cup.